Welcome to Quick Soil Mechanics Lessons with Brian. I'm going to continue with liquefaction simply explained in 12 acts. Done about 12 acts, but we're on Act 4, which is more circles and effective stresses. So if you remember, we have our axes, and we are looking at a isotropic consolidation where sigma 1 equals sigma 3 for the consolidation portion, and there's no shear stresses. We consolidate that out to where we wish it, and that's the initial confining pressure. If we put our failure envelope up there and remember our orientation of stresses on the triaxial specimen, and in triaxial compression, sigma 1 is increased, the vertical, and sigma 2 and 3 are held constant. So what we have is, if we look at total stress, currently disregarding pore pressure, we start generating a circle. That circle gets larger and larger until it fails, hits the failure envelope. And we talked about the circles that are all in between there, and there's an infinite number in between. There's the dot that signifies the initial confining pressure, and then the failure, and an infinite number in between. And we could put a dot on the top of each one of those circles to connect it with a straight line. And that line is at a 1-to-1 angle, and that is the MIT stress field. And now we have to add S and T to these axes. Sometimes it's labeled P and Q. We'll get into that in the next slide. Where S and T define the tops of those circles. And this straight line at a 1-to-1 slope is the MIT stress path.
Well, there's a second way to define stress path, and that is with P and Q as opposed to S and P. So here is the definitions of P and Q, and it plots this way with a 3-to-1 slope rather than 1-to-1. And this is the Cambridge stress field, and this is the stress path in Cambridge stress field.
Okay, now let's take a look at a Mohr circle and total stress. And we will see that there is a corresponding circle in effective stress if we have effective stress measurements in the test. And on the x-axis, we've added sigma in prime to represent the effective stress. And the difference between those two circles is pore pressure, of course. I think everybody has seen that. So we have on the left circle, that's the effective stress with sigma 1 prime, sigma 3 prime, the total stress on the right-hand side, sigma 1, sigma 3. And we have to add our effective stress friction angle to that. So let's see what happens. We consolidate our specimen out to our predetermined initial confining stress, and we'll look at MIT space with the top of the circle. So we have our first circle in total stress, and we have a matching circle in effective stress. So the difference between those two is the pore pressure. We keep on sharing that additional load, additional vertical load, sigma 1. We have a matching effective stress circle. We keep loading, and you notice that the red circle, the effective stress circle, doesn't follow any predetermined line like the total stress does. The total stress follows the same trend that we were looking at before, but the effective stress doesn't. And we grow and grow this until we get the failure envelope. So here's failure with the total stress, and here's a failure point in effective stress. Now again, we can connect the top of those circles in total stress and get our total stress path. And for our effective stress, we can do the same thing and connect that with a line. Now it's pretty messy out there, isn't it? So that's the beauty of just having these stress paths. We don't have all that racket going on. We take off those points because they're kind of meaningless. These are the connecting all the points on those circles. And again, this is the MIT space. And I think we're going to stop there for today. So remember, that's the total stress path, and this is the effective stress path. I think that's a lot to consider for one day, for one lesson. But you can see how much easier this is to look at the stress paths rather than all these circles. You can see how the circles moved to get where they are, and we'll talk about what they mean in one of the future lessons. But for now, let's call it quits, and we'll bring this to an end and hope to see you for the next lesson. Till next time. Bye-bye.